Marlbo Tech Talk.
Hi, so you're watching the newest episode of Marlbo Tech Talk. So as you know, through Marlbo Tech Talk, we aim to take the technologies beyond products, bringing you insights, real-world applications through conversations with experts behind them. And Marlbo is a leading supplier of testing, measurement, safety, energy, and industrial solutions with over 37 years of experience in the industry. So today we are talking about something that we may not normally associate with seeing, which is sound. We are all familiar with thermal imaging and how it allows us to see that the human eye cannot detect. But what if we could also visualize sound and use it to identify problems before they turn into failures? So that's where acoustic imaging comes in. To help us understand this fascinating technology, how it works, and where it can make a real difference in the industrial maintenance. So that's where acoustic imaging comes in. So joining us today is Mr. David Gambarte, condition monitoring specialist for the Asia Pacific region at FLIR. So David brings extensive experience in international sales, channel development, technology solutions, and business strategy. Today, he leads business development for acoustic condition monitoring solutions across the Asia Pacific region, supporting industries such as electricity, manufacturing, and oil and gas. And also, we have a very familiar face, Shevon Liyanage, our engineer at Marlbo. So it's a pleasure to have both of you here. So Mr. David, to start off, we hear a lot about FLIR when it comes to thermal imaging, but today we are focusing on acoustics. Could you tell us a little about FLIR's acoustic business and your role in this space?
Yes. Basically, what we are doing at FLIR is using what brings us with acoustic technology. So we are combining microphone solutions with AI filtering and a camera into condition monitoring. So we are working on providing with solutions and applications from those solutions that will actually help the work of our customers in condition monitoring. So simplifying solutions, making them to find what they need for their own decision making is our main target.
Okay, so since you're closely involved with FLIR's acoustic business, what was it about acoustic imaging technology that was attracted you to this field?
But when I first knew about acoustic technology, it was, we had different conversations about how the different applications could actually be working. And one of the things that was most interesting, I would say that is still really, really exciting, is that we have a huge open field of opportunities out there. So there are many things that we are already doing quite well. So we have solutions that are very sharp and efficient, but still we know or we foresee a lot of new applications that will actually open a lot of very good solutions for our customers or for different customers that we cannot even recognize nowadays, but they will actually become customers in the future.
So for someone who's hearing about acoustic imaging for the very first time, how would you explain in simple terms what an acoustic camera actually does?
Yes, of course. An acoustic imaging solution is basically a hardware device, as you can see them here, that has a frontal array of microphones, and the microphones are gathering sound from whatever environment. And when you are using acoustic imaging solutions, you are looking for certain phenomena, certain things. Let's say a partial discharge in a medium voltage or high voltage substation, or you look exactly a gas leak or a rotational failure. So basically, these microphones are gathering all kind of sound, and the sound is filtered out, and it just keeps the sound that is interesting for us, which is in the case of a partial discharge, it will show in a image where that partial discharge is located. So it's taking sound, filtering it out, and giving the right sound filter that you need for your own purposes, for your own work.
By filtering out, do you mean it filters out unwanted sounds? Say
Yeah.
maybe
are screaming in the background or
Whatever.
machinery working in the background. You filter all that sound.
Music,
and exactly.
Cars, engines.
Everything's filtered out, just focusing on the frequency range. That's acoustic, like that we're interested in. Basically a PD or a compressor leak or something like that. Right?
Exactly. So basically using the sound amplitude, the frequency, and the wave width. The cameras are recognizing a certain sound and they are filtering out all the unrelevant sound. So imagine you're in a factory, you have an engine here, you have a truck going on, a few machines making noise around, you have air conditioning systems, you have people talking to each other, someone is shouting out there, you have a person hammering 50 meters away, but all that sound is actually gathered by the microphones.
And then filtered out.
Yeah,
basically it's, as you said, thermal imaging works with, it visualizes heat. This visualizes the sound we want to visualize. Basically the sound that's important to us.
Yeah, exactly.
All right. So since FLIR first introduced its acoustic technology, how has this evolved over the years?
Acoustic technology, acoustic imaging technology in our case, this acoustic technology existed before already. So there were directional microphones and some kind of trumpet microphones and so other kind of devices that they were gathering sound as well. So we have seen that the evolution has been from, as FLIR, it has been from evolving analytics into a better match with the customer needs. So we want to simplify our customers' lives. So we need to give them the information they need for the decision making in condition monitoring in any kind of field. So basically we have been working in improving our analytics capacity in order to give the right answer, the right information for them. Another one has been related, of course, on the different applications. So we are finding, as I mentioned before, we are finding new applications and we are working on making them to be, useful for the customer. Sometimes you find a very cool application, but doesn't have any clear usability in the market or in our customer side. So we need to make them to be, something practical for them. In our case, as you could actually realize, our cameras has gone into a really short trip in terms of design. The design, of course, of the newest models, this is a new model camera, are much, maybe I would say, better looking, modern looking,
easy to hold.
More economic, of course.
And I think there's some practical uses that were seen in the upgrade of the camera as well, right? Maybe we could give them an understanding. This was one of the first cameras that you introduced, and this is the newest generation.
Yeah, this is the newest generation.
And maybe we improve the design so that you can keep this as a standalone device like this. You can make it stand on a table and maybe visualize something like a video, take a video in the long run, right?
Yeah. So yeah, I mean, as you can see, you could imagine that naturally a team of hardware and professional designers, they will actually discuss about whether we could improve the solutions or maybe change them. But we actually realized that we don't need to change the main spirit of the solution. So they are handheld devices that you can hold with one hand. They have a frontal array of microphones. They have the same, kind of a bit bigger screen, the newest one. We wanted to improve the screens. They have a bigger and better battery, place. But at the end of the day, we have kept the same spirit. What we have done is improving the design, improving the capabilities of the camera.
Okay, so when we talk about acoustic imaging, many people may compare it to a conventional ultrasonic leak detector. So what really makes acoustic imaging different?
Basically, the second part of the second word of the name, right? Imaging. So they are, as I mentioned before, one directional microphones and different kind of acoustic solutions, even contact solutions that are using acoustics, that they don't provide with an image of the region, of the area that you're inspecting. So the kind of data that you are getting is totally different. Then since the main advantage that we see when we started to, to experiment, to investigate what we can do with acoustic imaging was, wow, with an acoustic camera, you could just take it and look from a further distance, let's say 10 or 5 meters or even 20, 50 meters, 100 meters, look at a certain area, and in a fast way, you will be able to inspect it and check if there is, for example, a specific leak in a very far away line where there's, in a pipe where there's a gas. And then from that point, basically, you see the big advantage. So older more traditional acoustic solutions cannot do that. So acoustic imaging is providing efficiency, distance, and easiness to the customers.
Yeah, I think ease of use is mainly, I think one of the main points that we can focus on with acoustic imaging, because traditional ultrasound solutions, you have to take a microphone, you have to go around, you have to go through every leak.
It's very thorough. Yeah, you need to be
you need to be very thorough.
There are very good solutions, of course. I'm not saying the opposite, but they have different kind of approach, different spirit.
Yeah. And this is very easy to use. I think anyone, people will understand this kind of easily. Whereas in traditional ultrasound solutions, you need a person who's a little bit experienced, who understands what's happening, and who can interpret the data that they're gathering. So I'd say in that terms, acoustic imaging cameras are way far beyond traditional ultrasound applications. And I mean, it's for a different application, but this is for something like leak detection or partial discharge detection. I think it's a very good improvement, you would say, right? With that, Mr. David, I would actually want to ask you about the technology itself. So talking about the microphones and the beamforming technology, can you explain, without going very deep, can you explain a bit about how the technology works?
Basically, the microphone array is, as I said, is gathering sound with the directional microphone that they are composing it. So it's taking all the sound from a certain field of view.
Yeah.
So by gathering the sound is, as I said, filtered out.
Yeah.
So, and it keeps the location of whatever you're looking for, the phenomena that you're looking for. In this case, we can say a leak, right? The beamforming is like, algorithm solution that will, by triangulation, will exactly give the location of that specific sound that you're looking for. And then it will actually place the blob that shows that sound of the leak on the image that is actually, provided with the camera that is in the frontal side of the acoustic imaging solution. And that's basically it. At the end, you will actually get a certain phenomena on a certain image, and then by analyzing the characteristics of the sound, we provide with different analytics. Let's say, in the case of partial discharge solutions, we provide with identification of the type of partial discharge by interpreting the PRPD pattern, and then we provide with severity assessment, so giving an idea of the criticality of the specific partial discharge, and then we provide with recommended standard instructions for the users, of course, making their own decisions in their professional work.
So one of the major advantages of acoustic imaging is that you can locate problems from a distance. Why is that capability so valuable for the maintenance teams?
Well, I think it's a common global international issue. I think it's common everywhere. So you need very well prepared professionals. They have a short time for the work. Have shorter and shorter time. We are rushing with different kind of work protocols. The quality standards are every day more demanding. So normally, like in a kind of company where you have a maintenance teams or different engineers performing inspections, they are always short of time. They always in a hurry. They always need extra time to work. So what we think that is providing them, as an advantage, as you said, is we give a solution that is so simple to use and so efficient at the same time that they don't need to focus on learning how to use a new technology. It's basic, very easy to use. It will provide them with the answers they need for the work, and it will actually shorten the time of the inspections, as you were mentioning before. How thorough it should work, for example, with directional microphones or with sniffers for leak detection. In this case, you will take much less time for the same results.
So, compressed air leaks are one of the applications people are most familiar with the acoustic imaging camera. But beyond that, what are the other problems that the acoustic cameras help detect?
Yeah, I mean, the acoustic cameras, of course, compressor leaks, but since the cameras detect leaks, they detect leaks of any kind as well. So we are talking about leaks that actually happen in any pressurized system, whether it's compressor or even different gases. So we have a number of customers everywhere, all over the world, using the cameras for different gases locations, let's say hydrogen, oxygen, helium, ammonia. Yeah, a lot of different gases.
Vacuum leaks.
Yeah, the cameras can work for vacuum leak detection. So the cameras are giving the possibility of finding leaks that are not only just compressor leaks, that maybe they just have an impact on the, of course, on cost or have an impact on quality of the end product, but also on gas detection, on gases that can be explosive, dangerous, toxic. They can be very costly, they can be really expensive, and they can also affect the quality of the production lines or the quality of the end product. So that's extremely valuable from that side. Then just staying in the main applications that we have, the cameras find, recognize, identify, and assess partial discharges in medium and high voltage systems. So basically, in a similar way, the cameras will actually gather sound and look for partial discharges and give identification of the type of partial discharge and a severity assessment to the customers. So that's what's simplifying the work drastically. And then the cameras also, is another application that we have, are looking for potential faults in rotational elements. So you can imagine that there is a lot of machinery that have rotational elements. Let's say there are pumps, gearboxes, and couplers, turbines, and of course bearings and rollers in any kind of conveyor belts. So we have customers, for example, in the mining industry using cameras only for conveyor belts inspection, where they are looking for mechanical fault, because a mechanical fault in mining industry, depending on the conditions, might actually represent a very, very, very big cost. And by seeing that there is a potential mechanical fault somewhere, and by doing predictive maintenance, fixing something before it actually become a problem, they can save a lot of money. So those are the main kind of applications that we have nowadays.
Right, so now we talked about what these cameras can do. So how can acoustic imaging actually help companies reduce energy losses and improve overall efficiency?
What can they do for improving?
Yes, for reducing energy losses.
Yeah, well, basically the energy losses are related on the on leaks, right? So well, also on partial discharges, there are kind of breakdowns. But yes, acoustic imaging can help to avoid unexpected problems, basically. So you have an incident, in any kind of factory anywhere, that might actually become energy problem, loss of a lot of money, loss of time of production, and a lot of things that are actually related to, or they are going directly to the maintenance team. So basically, we can help, or our solutions can help our users, our customers, to be more efficient in the work, to easy it in a fashion that they can actually perform working actions or corrective actions or fixing actions before those represent a real problem.
Yeah, I mean, I'd say that all of the main applications that Mr. Davey talked about, that being leak detection, mechanical faults, and partial discharge, are directly linked to some financial benefits for all of the companies, because if you find something like a partial discharge very early on and take the necessary corrective actions, you can prevent a very big failure down the line. So that will cause companies to have like a significant amount of price reduction from what would have been a very big failure. And if we look at leak detection, whether it be compressed air or anything else, it directly relates to a financial income, preventing a financial loss. If you look at these leaks and you address these leaks, you can definitely prevent a very big financial loss in terms of the companies. And in mechanical fault detection, as Mr. David said, usually in mechanical components, ultrasound gives the first indication of failure. So you can use these cameras to see if there is any kind of bearing defects or any kind of mechanical fault, and looking at that and preventing a mechanical fault or say a motor failure, at least preventing one motor failure can benefit your company so much. So I'd say all of the major applications directly linked to some kind of financial benefits to the companies. So this is a very good device in terms of ROI and what a company gets back from it.
Maybe just to give one more point, a visual one. When we talk about partial discharge detection and monitoring, it's a common place in the industry where they think, okay, well, having like information of my PDs, I already have some solutions that give me information about the partial discharges, right? So PD is partial discharge, but in reality, if you have information about where you have some partial discharges, maybe once a year or once every 6 months, and you don't monitor them, you don't monitor the evolution of the partial discharges, even though they can be mild. Many of the partial discharges are mild; they require no action or like a very simple action on them. When you are performing maintenance actions that are quite expensive in the electricity industry, that require even like putting the systems offline and
even that's a cost.
Yeah, that's a very big cost. And the thing is, if you have been using acoustic imaging for a certain time, a few months, a few years, and you are actually keeping the data, and you are reporting the data, and you know where your partial discharges are located, how is the evolution of the partial discharges, you have your systems under control. In that sense, when you stop or you need to make a maintenance action, you already have all the data, all the information, and you can, for example, this is a speculation exercise, but you could foresee, okay, this partial discharge has been evolving in this way, and I don't need to take any action because this has been stable for 2 years. But on the other hand, this partial discharge has been like getting worse and worse and worse. And like this worsening can continue like this. Maybe in 8-10 months, I might have an issue here, like a severe partial discharge. So in that moment, having that information in place, you can basically, when you're doing a maintenance action, you can basically make the decision, okay, I will fix this one because this is, the tendency is showing me this. So there are things like this that by having a protocolization of the use of acoustic imaging, you will be able to be much more efficient in your maintenance actions.
All right, so looking at maintenance broadly, where do you see acoustic imaging fitting into a modern predictive maintenance program?
Basically, as a common target for everyone, we are looking at being more efficient and having better information, right? So, as long as we can actually integrate better and more acoustic imaging solutions as well as thermal solutions and other kind of condition monitoring solutions, of course, into the workflows. And these workflows are actually providing with the right data and the right moment, will actually be able to improve the efficiency of the condition monitoring teams or the maintenance teams. One of the main things will be, having systems that will go specifically into asset monitoring, and it will easy them in a way as we have, for example, with our Asset Link, as a new platform that is kind of an overall platform that covers all the technologies and allows the customers to have asset monitoring and work with trends and have work plans work actions appointed and so on. So work orders appointed. So I will say that that's a way of getting modernized in a fashion where the solutions are just a, a part of the tool set that they need to use for decision making, and the solutions is they are not a central thing for them. They use the technologies and they basically make the right decisions for their own production, so customers can work and can focus in what they need to focus, right? in in producing better quality product, producing more electricity with more efficiency, and making their lives easier basically.
So acoustic imaging doesn't necessarily work alone. So how can it complement technologies such as thermal imaging and vibration analysis?
Well, there are many complementary uses or like combined uses. I mean, one of the main things that we always communicate when we're visiting a customer that is not using acoustic imaging or they are not very familiar with it, is that we are not trying to replace anything. So acoustic imaging could be a very useful tool for you, but we are not saying to stop using your different sensors, even from other technologies, not only vibration sensors or thermography, but other kind of technologies that are out there. Um, we don't want to replace anyone. We give a solution that make their lives, a bit easier. The combination are very broad, but maybe the most clear ones are related to some issues like in rotational element failures, in mechanical faults, even partial discharges, and some actually leaks in certain specific places might become a problem of a change of temperature of the surface of the systems or the panels or whatever. And in those cases, the solutions may actually be complementary to give a better understanding what's going on there. In some cases, actually, you will have an early sign with acoustic imaging that will actually find that there is something somewhere, and after some time of maturity of that specific phenomena or issue, the temperature might change. You can actually use thermography. Yeah. Another example will be that when you're using mechanical fault detection, there's a very clear, straightforward case of thermography, acoustic imaging, and vibration. So all three are extremely complementary in order to have a proper analysis of the mechanical faults. So you can, let's say, you can do a scanning of a certain area of a like conveyor belt where you are like conveying moving boxes, like very heavy boxes of 100 kilos each with rollers. Basically the camera will tell you, okay, where there are kind of incipient problems or where there is something that could be a mechanical fault, and you say, okay, I want to get a deeper analysis. You go with thermography and you check if there is any kind of heating problem there that actually might become a problem earlier, and then you can actually place, for example, vibration sensors and say, by analysis of the fast forward Fourier graph, you can actually check, okay, this is actually a mechanical problem at this level, and you can actually get some further analysis. So yeah, I mean, you combine data and you make a proper decision with that. So there are many cases which you could actually.
Okay. So now I'd like to move to the Sri Lankan market. So Shevon, from your experience here, where do you see the biggest opportunity for acoustic imaging in Sri Lanka?
I mean, as Mr. David mentioned, there's a huge landscape, a huge amount of markets that acoustic imaging can be very beneficial for, especially in Sri Lanka. And we've visited a lot of these companies. We've visited and done demonstrations, and from what we understand is even the people in Sri Lanka have a very keen interest to adapt these technologies. But I've seen that from all of our visits that the interest is mainly for something like compressed air leak detection, because these problems are still not addressed properly, or there is no proper solutions in the Sri Lankan market yet for solutions like this. So I see a rapid or a huge amount of companies that are interested in compressed air leak detection and other kinds of leak detection, like especially food and beverage industries. They are really keen on what sort of gas leaks they can allow in their industries. So they are a very interesting customer. But in the partial discharge space, utilities very interested in this, because as Mr. David said, it's a very, very easy technology to use. You can directly see all of your partial discharges or leaks or mechanical faults. So there's a huge landscape of market, especially for Sri Lanka as well. And I would say more heavily leaned towards leak detection. But I can see a gradual development of other markets as well, and gradually adapting these technologies into our day-to-day maintenance work.
So yeah, what do you think is the biggest barrier to wide adoption of acoustic imaging in the Sri Lankan market?
Good question. In the Sri Lankan context, I would say we're still pretty new to condition monitoring in general. A lot of Sri Lankan companies are just now beginning to adapt proper predictive and preventative maintenance strategies. And there's a gap where maybe people are somewhat hesitant to go to new technologies. They're hesitant to trust new technologies because a lot of people, especially in Sri Lanka, work off of experience. They know that with their experience, they can say that this machine is faulty or whatever. But as that generation slowly goes out of the market, there is a big gap where we require either specialized people, or we require specialized technologies that can help these people to or these industries to get better results, or know their assets better, like know how their assets are performing better. So what I would say is people fear some technologies. So there is a bit of a fear. They are mainly scared that they'll have to do more work, because see, I'll take something like this for an example. I visited an industrial plant recently where we have showed these leaks, and the engineering team was very satisfied, and they really wanted this product. But the technicians, on the other hand, didn't really like it. They were like, this is going to increase my workload more. I'm going to have to fix these leaks more. I'm going to have to spend more time fixing these leaks or doing whatever. So they are worried about the workload increasing. But I think what they don't realize is, by doing that workload now, they reduce a huge amount of work they have to do in the future. And as our Sri Lankan industry sees this slowly, I think they will definitely adopt these technologies. But the fear of these new technologies and the inability to comprehend some of these will be some of the reasons why it's a little bit slowly being adopted. But we'll see a rapid growth in the future, I'm pretty sure. If you look at how the markets have evolved, especially in Europe and in America, I think some kind of similar thing will happen in Sri Lanka, and we'll be adopting technologies like this way more rapidly in the future.
So, Mr. David, coming back to FLIR's acoustic imaging solutions. So now there are different solutions for different applications. So when a customer is looking at these options, how do they know which is the right solution for their application?
Basically, the customer will, I mean, naturally, there's a work that we all need to do into discussing with the customers and helping them to be driven to the right place, in the sense of they know what they need, but they might not know what is the tool that can help them for that.
Definitely.
So it's our call, right, to help them. And for that, of course, we also need to be very clear and very transparent with everything. So this is a bit of a digression, but we have to be extremely honest with that. So sometimes a customer needs something and they think that a certain solution will help them, a certain hardware, and that's not exactly right. So this solution will actually help them. So we need to be very clear with that. Said this, I will say that the best way of a customer to understand if the solution is giving them what they need is looking at two things. So what are the outcomes? And the outcomes can be also in the software. like in, as I said, Asset Link or in our acoustic viewer. Acoustic viewer is the specific software for the cameras. The Link is a more global condition monitoring software. Or in the analytics that you get in the camera, is this what I need? The second thing, and extremely important, fundamental, I will say, is this camera in a practical use when I go and perform an inspection, or when my team goes and perform an inspection, is this going to be fitting with our needs and characteristics? Because if you have a camera that will not be useful for them because of some limitations, some team, like mobility issues, for example, in the area that they need to monitor, or anything, if the camera in practice is not actually helping them to be able to perform the inspections and gather the data, they will not be able to use the camera, so they will get a really minimal benefit out of the potential benefit that they could get. So those two things, analytics, so basically the information they use for the decision making, is it the right one? Second one is the camera, or are the camera characteristics allowing your inspections to be done in the way they need to be done? I would say those are the two main things.
With that, I think we can also hone into like FLIR's acoustic imaging in general. Then, could you maybe tell us or tell our audience what differentiates FLIR's acoustic cameras from the other camera or technologies in the market currently?
Well, I mean, I can naturally not talk about other manufacturers. But
what are the key benefits from FLIR's acoustic camera?
So we have a very clear direction, right? With our technologies, we want to have easy to use technologies. We want to simplify our customer work. So that's our message for them. But internally, we need to give this message internally and continuously, right? So is this solution or this new application or this new, let's say this new feature or this change in an acoustic imaging solution, is it helping our customers to have a easier work or not? Is it giving them value or not? So our maybe differentiation, which is like totally fine, basically, we are not saying that other solutions are not good. We just say that we work in the direction of making our cameras to be simple to use, easy, to go out and do inspections. The data has to be very clear and very on the spot on what the customer needs, and they of course they need to be reliable. So for us is, no matter how many features you have, no matter what your spec sheet says, if your cameras are not reliable and they don't have replicability patterns where you can actually go and be sure that you will find the partial discharge or the leak when it's happening, and they will not find the phenomenon that you're looking for, then your cameras are not working. So you need to have cameras that are reliable in terms of efficiency and performance.
So finding a problem is one thing, but understanding how serious the problem is can be even more important. So how does FLIR help users understand the severity and the potential cost of the problems they identify?
I mean, in terms of leak detection, acoustics is pretty straightforward. Basically, we estimate the leak size, and by knowing the leak size, for example, in liters per minute, you will, of course, knowing the cost of the compressor, in the case of compressor, or how much electricity your compressors, so you have your own compressors, how much electricity the compressors are using for producing the certain amount of compressor, or how much is the cost of a gas. Like you buy gases and you're using them in your systems, that will actually give you a straight answer, right? So volume of a certain leak in liters per minute and cost of that certain gas is already a cost. Naturally, there are other derivative costs that might actually be higher if we think about safety, accidents, problems in quality, or you need to stop lines because you have issues and you cannot actually keep on working. That's really costly as well. But that's more difficult to explain here, or basically to quantify with a camera. Another one related to the partial discharge that you mentioned at the beginning, the camera basically provides with the severity by estimating or taking data from the sound intensity, which is called SPL, so the decibels, analyzing the sound intensity of the partial discharges, identifying the type of partial discharge, which is fundamental. You need to know the type of partial discharge, knowing the asset where the partial discharge is happening. So it's never the same to have a partial discharge in a normal insulator than in a cable termination or in a transformer. So totally different things, totally different severities, and also knowing the voltage, of course. The voltage of the systems are fundamental. So of course there are other factors, but those are the ones that are in a combination, can provide you with a severity level of the certain partial discharge.
Okay. So looking ahead, what are some of the most exciting innovations you're seeing in acoustic imaging?
The most exciting innovations, I guess they are related on the simplification of the workflows. So we need to keep on using AI. We need to keep using our ability to simplify our customers' work by using different tools to make them to go into inspections and be even faster and more efficient. So maybe it's not the most attractive innovation, so it's not like having a device with a different shape, but it's what we see that it gives value to our customers. Another one will be related also to the way of sharing information among the teams. That will be related to communication protocols, and we are also working on them. And then there we can actually do a lot of more work. As for example, in FLIR now we have the IXX solutions, the new Android-based thermal cameras that are actually allowing a huge field of different applications that are related on communication, on sharing workflows, or sharing reports, sharing information, even like overseas with someone who is sitting somewhere else in I don't know, in Europe, and someone is sitting in Japan. So that will actually be also a very, very good step. We are working in that direction. We also having solutions in that direction, and there is where I can see that we can actually do, we can do a really good job. There are other things maybe related to new applications that, we are gathering sound. So if we gather one kind of sound and it's giving value to our customers, there might be other kind of sounds that we can gather and filter and can give value to our customers. Without going into the specific ideas that we might have, we foresee that there might be some sound that we could actually do with a similar process, right? Gathering them, filtering the unrelevant sound out, and giving analytics or information about them that will actually give a lot of value to many customers, or maybe to customers that are not even in our minds now. We don't know them, and there may be potential customers in the future, and we don't even know that they could be potential customers now.
Basically, we can expect many more applications to come. Something like that.
Yeah, working on that. So that's the main idea. So yeah.
So without giving away anything confidential, what can you tell us about the future direction of FLIR's acoustic products?
Well, in this sense, we can even say that we are now in the future, because the future is now, because we launched a new acoustic solution, which is a fixed acoustic camera, like aiming to do 24/7 monitoring of critical assets in medium and high voltage. So imagine that you have like a transformer rooms, and you want to avoid any kind of issue in that transformer room. You can place 1, 2, 3, depending on the structure of it, but you can place different fixed cameras to monitor certain assets, and you will have a continuous monitoring. And by describing the areas of interest, or you say, well, I'm looking at this, but I don't care about what's happening around. I care about what's happening in the transformer area. So you set up the area of interest, and the camera will basically look at that area 24/7, and you will get notifications. So the camera is already, of course, in the market, and you can get notifications out of what is going on in your assets, and then you can actually get the trends and to decide also in condition monitoring, kind of work plans. So yeah, the future, as I said, is basically this that we are launching, or we launched a few months ago, and they are the fixed acoustic solutions to work installed in different places for critical assets monitoring. And of course, there will be more fixed solutions to come soon that will have different applications.
So I think we've covered a lot about FLIR's acoustic imaging solutions. So as closing remarks, Mr. David, what advice would you give to engineers who are looking to adopt this technology?
Yes, if we're thinking about the bias of any engineers that will like to adopt, or they're considering to adopt acoustic imaging solutions, I will get back to what I said. So look at what this acoustic imaging solution is giving to you in terms of data analytics, and look at your work processes, the way you need to work in order to get that tool on place for the inspections. So if those things are matching, that solution can be a good one for you. So I will say that you need to look for a solution that is matching with your conditions of work, giving you the data you need, and then naturally a solution that works well. As we say, we are looking at at the efficiency of our cameras and the simplicity as the biggest feature that we can actually give to our customers. So they need to be performing in an efficient way in any conditions. As you know, also as a closing remark, I would like to say that it has been really impressive for me to work with you these days here. Your work is excellent. We have been changing a lot of information. I've been learning a lot. I'm sure that any customer who will actually approach you to buy acoustic imaging solutions will get the best possible understanding and the best service that they can get in the country. So I'm hoping to have more work here with you, with Marlbo in Sri Lanka, and hoping to come back again, and maybe eating a little bit less because I ate too much, but, because the food is very good. But besides that, I ate too much. Everything has gone really well.
So it's been a great conversation, Mr. David and Shevon. So we've looked into acoustic imaging today. It's about visualizing sound and identifying problems before failures. So with technologies such as acoustic imaging, engineers have the opportunity to identify problems earlier, make informed decisions, and prevent costly failures. So if you'd like to know more about acoustic imaging, you can contact Marlbo. Our engineers are here to help you. And thank you so much, everyone, for tuning in today. So if you do not want to miss our future videos, please subscribe to our Marlbo channel, like us, and turn on the bell notification. Thank you for watching.